All right, I think we are live. If all went well, we are live. Keep this animating. But let's verify, because it's always good to do. All right, I see live. Does the chat work? Sometimes the chat doesn't work. Let's make sure the chat works. Okay, I can see the chat. We are golden. Now, I talked to myself in the beginning because no one's actually here yet. But I'm just going to dive right in because I have a lot to get done tonight. And let me just get off of that. Where do I get to the dashboard for this? Which one am I running? DirectX. Okay, so this project works fine because I fixed it. But the problem is all my other projects are going to be broken. So let me see. Which one is the one? This one. It's the other one I want to get to work. This one's going to be completely busted. Yeah, of course. Okay, great. I have to fix all this. So this doesn't exist anymore. Actually, let me see. I'll only do that in one spot. Fix that error. Here's the fun part where we just go step by step. I'm actually not even using this file, so I'm just going to delete this whole file because I'm not using that. Okay, so thankfully I did set this up kind of intelligently when I did it the first time. So all of this goes in here. And then all of these shader bind calls need to become commands. A bit bigger. Let's see. That can be small. That can be small. So update this. Interesting, I'm not setting the cull mode in this. That should be that. And then that becomes that. It's a long line, but it's fine. Delete this. I guess we can put that up here. That should be fine. And then what's next? The frustum. Sky does not need to write. Depth. I think that just becomes that. So I'm already doing this in here, I believe. And then for now, we'll just turn off the UI just to see if this will work. I know I'm gonna have a bunch of errors still, most likely. Yeah, of course. So, let's see. Yeah, it does not like this stuff. So all of these need to be converted to the render commands. Is this the outline? Yeah, it is. Okay. So we render here. Where do we actually draw stuff? Here and there. That. All right, now we just need to fix these deprecated things. Where am I calling that? Let's see. Wait, what was the problem there? Oh, call mode. Let's... So when I draw the level, it should be fine. It's always a great sign when you can't see anything. Oh no. Alright. So it actually is rendering, I'm just not seeing it. It's not like presenting the final image to the swap chain. Alright. That's actually good because everything looks like it works on the side here. All the draw calls are working as I expect them to. So why didn't it composite? Is it because I turned off this? Probably. So let's see. I guess I don't need this. And that's turned off. No, that didn't do it. Interesting. Does not like that. Okay, I'll have to fix that. OpenGL is more finicky than DirectX, it seems. I have like some weird edge cases where OpenGL just doesn't work. Okay, let's see. I'm surprised, that should have worked. Oops. Yeah, so we do the forward rendering, and then what are we drawing to? So the output is the swap chain, the input is an empty texture. And that is what? Swap chain. Let me draw a bunch of text, and then, yeah, so something here isn't making it. So this call isn't working. Pass begin, pass end. And then this should just work. Let me explicitly bind this once. Let's see what happens. That's so odd. So this is definitely the pass. Let's see. Is this actually binding in DirectX? So that calls that, which goes to there. And then, yeah. Where's the what's it called? API inspector. There we go. Yeah, so it is binding it. It's just not reading it correctly, which is odd. Let me see. What if I create this as a command? Composite. Composite. Is it like trying to depth test maybe? Oh, it might be trying to depth test. That would make sense. Potentially. If I do it as a command, it should work. Okay, that's progress. Oops. Let's turn off all of this. What do you mean it can't bind shader program? What are you talking about? Failed to bind shader program. What? Is it the viewport? It's weird because this is like the least complicated step it has to do. Like it's doing all the rendering here perfectly fine. And actually this looks a little wonky. What's going on here? That does not look like the texture I expect it to be. Okay. Whatever. But then when it comes to actually compositing this thing, it fails catastrophically. But at least it's getting it as an input now. It's just writing it to the wrong spot. It's like it's not getting the viewport or something, or the matrices. Let me try putting this in the command. Oh, there we go. And then this is just not depth testing. Is any depth testing working? I guess depth test is off by default, so I need to turn that on for all of these tests. Let's see. So like command set depth test. I guess I could put all of this stuff in a... Let me see. If I uncomment this stuff now, what happens? So it's like working except for full screen now, which is interesting. I wonder why that is. Is it because... No, that's not it. It's like it's not resizing this. Okay, it is resizing. So that's not the problem. Bizarre. It's interesting because it like zooms in as I make the window smaller. Does the console work? That's bizarre. Does the other project do that? No, the other project works fine. Oh, that worked. It's like something's going weird with like my Windows. Like Windows like operating system. Why did that work? What is going on? What is happening? It's like inconsistently broken. Look at this. It's crazy. Okay, that's a problem I look into at a future time. Because that is really annoying. Oh, I didn't even see the chat's not working. Here I am thinking no one's talking. 1 second. My bad. I've just been like not responding to people. What happened? Why'd chat stop? It's not working on Twitch anyway. Let me make sure the chat works. Ah. Did it work? I think it worked. Well, if anyone that asks questions is still here, I'm working on some changes to how I'm organizing graphics, render calls, I guess, in my graphics abstraction layer. Sorry, I just have to make sure the chat's working. Something just like catastrophically failed. Yeah, now YouTube doesn't work. What is going on? I'm sure there's a better way of testing this than spamming test to myself. There we go. 3 tests. Okay, well hopefully I don't ignore questions anymore, because now that I can actually see the chat. But yeah, I'm working on graphics code, basically. And I've done a refactor where maybe I can find a project where it's not, I haven't fixed it yet, and then one where I have. I'm actually not sure which one I'll use. I compile with, well, I have my own build system that runs, so it basically like scans the project and finds all the source files, and then like creates its own, like, I guess, script that runs the compilers. But it ultimately generates a Ninja file, and Ninja is a build system that's, I guess, kind of popular. Like CMake uses it as one of its backends for like actually interfacing with the compiler. But it uses like MSVC, Clang, and GCC. So I use all like 3 of them. But to actually compile in VS Code, I have my little I have like a little extension I made that kind of just gives me hotkeys and buttons to make my life easier in regards to that. But yeah, anyway, I'm working on, well, I've been doing this the last couple days actually, but I'm streaming tonight because I've gotten to a point where you can actually see stuff. So I've basically been like, I'm planning on, in the very near future, getting the Metal backend implemented for the Metal API, so I can use like Metal natively on Mac. And then I can move on from OpenGL 4.1, which I've been limited to because that's like the latest version Mac supports, to use version 4.5 or 4.6. Long story short, I want to start supporting the newer graphics APIs, because up until now I've only been using OpenGL and DirectX 11, and I've been thinking more about the graphics sort of abstraction that I've done, and I realized I was kind of doing it not in a bad way before, but in a way that's kind of contradictory to the way the modern APIs are designed to work. So I've just been refactoring that. So basically I added the concept of the render pass and then like render commands. And then I'm kind of rewriting all of my existing code to use this system instead of, I guess, the system I had developed before, which was more like akin to the way OpenGL works, where you just kind of like set state in sort of a fixed function way, like a giant state machine. Whereas this is more like you basically fill out these little graphics commands, and then you have like work that you execute based on that. But this translates really well to the way like the modern APIs have like the concept of a pipeline state object, which is basically like the current shader that's bound, and then a few other like graphic settings that sort of get baked into this one little object, independent of draw calls. And then like a render pass is like a collection of those. So yeah, if that makes any sense, that's what I've been doing. But I've only just recently like made this new API. So all of my old code is kind of broken at the moment. So like this project is kind of working again as of the last, 5 minutes. And I got the globe project working the other day. So this one uses the new sort of abstraction layer. And then this game, Vitality, is currently in a broken state. So you can see it's not quite working correctly. If I actually render dock this though, it is working. So like render dock. And like I can see that, the game is rendering fine. It's just like some of these render passes are kind of busted at the moment. Like I think it's actually this pass that's currently breaking it, yeah. You can see my little guy here. But I still need to do some work actually on the system too, because I'm not fully done implementing it. So I kind of have like this hybrid implementation of both both ways of doing graphics. I have like the fixed function way that's implemented, and then this new like, I don't even know what this is called. I'm not even sure what you describe this as, like render pass based architecture. So I need to gut out all the old stuff as well. But I need to figure out why this project is busted. And I'm stuck in render dock. Of course I am. Yeah, so this one's acting weird when I full screen. I don't know if that's just my computer, because I just did a Windows update, like literally 20 minutes before I started the stream. And I've never seen this problem before. But I'm also just changing a bunch of graphics code, so who knows? Well, the idea is it's going to support like all of the graphics features, I guess. Right now, it's kind of a bare bones version. Like I don't officially support compute shaders yet because of the OpenGL limitation I just mentioned before. Because I support Mac as one of my build targets, like MacOS, but I don't have Metal implemented yet, so I'm kind of limited to the latest version of OpenGL that Mac still supports, which is annoyingly the version like right before they added all the modern stuff like compute shaders and just all the new fun stuff. So I'm being held back at the moment, so I need to get this stuff done. But yeah, so it's obviously gonna support like the main rasterization pipeline, and then like compute shaders, and then maybe some ray tracing stuff if I want to get around to actually implementing some of the hardware support for that. But yeah, I'm just working on the engine right now, so like it would be up to each game to implement the actual rendering features of the game. Yeah, like yeah, like you mentioned forward and deferred. Like those are techniques that a game would implement for like its own render loop. So, well, at least the way I'm thinking about it is I'm working on the engine generally. So like the engine shouldn't care if it's a deferred renderer or a forward renderer. It's just like, how do you actually use the graphics APIs to set up a forward renderer? How do you use it to set up a deferred renderer? And this graphics sort of abstraction layer that I'm making bridges the gap between all the underlying APIs and should in theory make it possible to just set up a forward renderer or a deferred renderer, regardless of which, API is actually under the hood submitting the draw, talking to the graphics card. So yeah. My thought is that each game should like be responsible for setting up its own rendering pipeline, because like some games you have like very specific, you know, rendering style. Like one game might work fine with a forward renderer, and another game might work fine with a deferred. Yeah, it does, and I'm pretty sure it's natively part of OpenGL. I think it's 4.3 actually. I don't know. I have to look it up. It's annoying because it's like, yeah, 4.3 according to Google AI. It's annoying. Yeah, I'm just gonna assume this is right because, you know, AI is never wrong. Just joking. But yeah, Mac or Apple deprecated OpenGL after 4.1, so it's super annoying. And it's annoying because I have a Mac that I actually develop on. Like when I'm on the go, because I don't know, I actually like their laptops, so I want my engine to work on Mac, if only just so I can like work on it when I'm not home. But it's like a lot of work because now I have to implement their API just for like Mac. Now I actually kind of like the Metal API. I have a separate project where I've been experimenting with getting a renderer set up, and then the idea is I'll just kind of port it into this one once it's ready. Anyway, I'm like not even doing anything right now. Yeah. Yeah, actually I'm not too familiar with mesh shaders. I've heard about them, but I've never actually used them or messed with them before, played with them before. Okay, so anyway, why is, if I do OpenGL right now, I'm getting an error, so I need to figure this out. Wrong project. It's annoying because it's like, I don't know why Apple is so hostile towards like the greater community of developers. And it's not even that Metal's a bad API. Like I just said, I kind of like using it. It's not like it's a well-designed API. But it's like in a Mac, they don't natively support Vulkan either. And I know there is like Molten VK, which basically lets you program Vulkan on a Mac, but it does an emulation through Metal, so it's not even like true Vulkan. It's like an emulated version of it. And that's what like a lot of people do, is they just use Molten VK instead of supporting Metal natively. But I don't have Vulkan implemented either, so it's like, well, I have to do one of them. I might as well do both, you know? Okay, so did I error? Oh yeah, I'm not in OpenGL. Okay, so we have an error. Failed to bind shader program. That's such a crazy error. Where'd this happen? It's like the only reason this could fail is, I guess this could have failed prior to this. In fact, like if I run something up here, pre-error. Yeah. Okay, so I have some bad OpenGL state happening because I'm erroring. Now the question is, where am I erroring? Let's just... I don't have a good way of just spamming a check for this. Let's do the classic error checking thing. Let's create like a little struct. Then you have a constructor that will check the error, and it will say pre-error, and will tell us what function this started in. Stop. Let's. This is the classic scoped error checker that you just spam in every function and hope you find the error. Oh man, I'm not gonna have to. Yeah. Should we write some super gross code here? Call this function. Now we just spam this thing everywhere. Let's see. C++ 20 is what I'm using at the moment. For no reason other than that's just the one I chose when I set up the project for the first time. All right, let's see. Where do we spam this? Basically everywhere. Let's spam this somewhere where I know the error is happening though first. Shader bind. Just to make sure my little debugger is working. Oh wait, I'm right here. So we do. Oh, you know what we could do? We could turn this into a lambda or into a macro. Ooh, I have a seg fault. It's crazy. Really? What did I do wrong? Does it not like the SN printf? What? Can you not copy a function? Here, let me just store the pointer to that. I don't know why I was doing this crazy thing here. What? Seg fault. I'm not even using printf anymore. What? Where? What is happening? Let's just not even try printing this. All right. Header files. I am king header file or team header file. I don't find any problems with header files, really, if you use them correctly. Header files can be dangerous if you have, if you're not careful with what goes in them. Like, you could really nuke your compile times by having like very large header files. But if you're careful, then it's perfectly fine. And like my compile times are really fast because I'm just careful about how I organize my header files. I'm surprised I can't print the function. Did that really fail? Is that really a seg fault? That's crazy. What's the technique for doing this? I do this in other places. Oops, function. That's crazy. Yeah. I agree. Okay, whatever. It's this little check error thing, which is maybe I should just print instead of posting the error. So if I like printf, does this work? Maybe it's doing some weird thing. Can't type. All right, that worked. I'll just print my own errors. Okay, so how does this work? Something crazy's going on with the way I'm doing printing. So if error does this work? It's kind of funny how by spamming errors, I'm actually running this fine. Well, I guess I'm not running it fine. Like I said, before when I detect an error, I was actually just like aborting the program. Yeah, let's exit after this. Just exit with an error code. So if we detect an error, we'll just print it out. Okay. Let's put this in a little macro. We'll spam this, basically every function until we find which one is the one causing us problems. Well, I guess we have to wait in all the functions that actually change state, mind you. So any of these, basically. I should just leave this in the code permanently, to be honest. Maybe this will help me find the issue with full screen as well, if I'm lucky. No, I haven't got it yet. So here. Surely I've caught it by now. No, really? Wow. I'm just like in an error state from the very beginning, huh? I did change that to be post, right? Yeah, okay. Wow, I have so many random functions. That was pre-API init. Wait, what? How was that possible? I haven't even initialized OpenGL yet. Obviously, it's not gonna work. All right. So it's prior to vertex buffer current, which I call where. All right. So we're not done yet. We have a lot of stuff. So we have a draw call, next instanced. Okay, we've scoped every function now, so if we don't find it, draw instance, here we go. So it doesn't like this function. Why? Draw instance. Where do I call this? I know where I call that. I guess, wait, I have a call stack. What am I doing? So it hates this function. And I wonder what the reason is. It has a shader. And it has data. Is the... What test is this? Oh, that's where I'm drawing with... Is this the right shader? Shader. Yeah, that is the right shader. Let's see. Okay, so I guess the question is, what doesn't it like? What are the values of these? See why, when this can fail, let's see. Ouch, my eyes. So, if mode is not point strip, so which of these am I getting? I was getting, what was the code? GL enum. unsigned int. So you. So 1282. It's like the classic. What enum is this? Invalid value. So right, that is what that is, right? Why is this in hex? It doesn't help me very much. Okay, I'm getting invalid operation. GL invalid operation is that one. Yeah, this one's 502, which is 1282. So what could cause that from that function? I just close the docs. Where'd it go? What was the function? If a non-zero buffer object name is bound to an enabled array and the buffer's data store is currently mapped. If a non-zero buffer object name is bound to enabled array. So I'm not unbinding a buffer to an array. So let me see, let me think. So I might not be binding. Where do I bind this? So I think I was just getting lucky before that wasn't erroring. Because I guess... I think this is the problem. This should work now. Yeah. So... Alright, that makes sense, I guess. I have to clean this up because this is kind of disgusting. But the error, in case anyone cares, was that in this draw call, let me get rid of this so I can get the error position back. All right, so I'm getting this error in this function. I'm checking it from that. So yeah, this is happening from, where is it? Here? No, here. Somewhere up here. Yeah, here we go. So as one of my tests, I was doing a draw call. That is, it's like a pure draw call with no vertex buffer or index buffer. And the shader, this little test shader, this shader particle thing, is up here. So my vertex format is empty. And I was relying purely on the vertex ID to like generate my my points. I guess not generate them, but like there's no payload in the vertex format, so it's empty. And this call lets me submit like a vertex count that I want to draw and like how many instances of, I guess, 4 vertices in this case. And in OpenGL, I guess, which I somehow wasn't hitting this error before, probably just because I got lucky with the state. But in OpenGL, you need to have a vertex array bound. Where is this? Yeah, so you need to have an array bound, I guess. Otherwise, this function, any of these functions, I suppose. Where am I? This function will fail. And I guess this never caused it to fail before because the order in which I was drawing stuff, I guess, meant that like when I bind these, I don't unbind them because it's kind of, you don't need to do that. All right, yeah, thanks for stopping by. I appreciate the subscription. I'll probably stream again on Sunday. If you are around that day, I'll be probably streaming. But yeah, so basically to fix this error, we need to create an empty vertex array object. And I'm just sort of lazy initializing one here, but let me do this in a slightly more clean way. Let me think. So we can do that, and then in OpenGL init, wherever I call this, we can just generate this thing, and then we have to make sure we free it. What does that take? GLUint. We can just put this statically up at the top somewhere, I guess. Wherever I have my random static state stuff. Up here, maybe. Okay. Yeah, because for context, the little this is what that shader's drawing. He's drawing these little squares. And full screening works on OpenGL, which is interesting. It's weird how my mouse moves when I full screen. Okay, let's see if there's errors in Vitality when it runs as well, because this is actually good to have this error logging stuff. Let me formalize this little OpenGL error checker while I'm at it, because it's actually really convenient to have this in the code. So what do I have here? I'm gonna go back to causing that error, triggering that error. So I can improve my my error stuff. Hey, how's it going? Welcome back. Alright, let's see. So if I print line this is gonna segfault, I think, for some reason. Wrong project. Oh, actually, that was fine. Okay, let me see. Some fancy, this music's really loud, at least on my end. Let's do some fancy error logging. So we print the error, and then we put the function. And then we'll just print the call stack. And we will call this good enough. Let's just put this into a neat little message that actually gets printed as well. Why did I print it twice? Am I going crazy? And it didn't print the function because oh, that makes sense. Put the wrong thing. There we go. We don't need the new line. I will say OpenGL state error. Do a tab here. I'm really peculiar about my oh, I don't have the tab thing here. What? I want a 4-space tab. This matters. There we go. Looks good. Okay, now let's put this up here. I have like too much weird error checking. So if compile debug, this macro will actually do something. Otherwise, what should we name this? All right, perfect. See, now in debug build, we get errors, and then if we go to release build, we don't want to have all this extra error checking boilerplate going on, so we get the actual error. Now let's clean up where I use this, because I just spam this around haphazardly. So we will put that like there. Wow, I really did use this a lot, didn't I? I wish there was a way to like Strimler. I wish there was a way to do this with without having this like macro just spammed in every function. But that's fine. Oh, I didn't do it here. You never know. I'm just making sure I have this like in every function. Yeah, okay. I guess these can also fail, so we'll Check errors after initialization. I kind of want to inline this. Wait, inline this. Okay. Okay, actually I have to see something. How bad does this look? Oh, that looks pretty bad. Let me that looks horrible. I'll just leave it as is for now. And then I do check error. What do I call this function? Check error. Where is it? GL error? Checked error. Yeah, that is it. I should make these macros consistent with each other. Do I use this anywhere? GL error? I do. Should be a GL enum, and that should be unsigned. Okay. So there's my little error checking. I can't see my screen. So my little error checking little hack. And now I can move on with other stuff. Now that we solved this problem. How ugly did I make this file? Let's see. Oof. Alright, not too bad. It's just a bunch of the same. So let's so now if we run Vitality with OpenGL, do we get OpenGL errors? That's the question. No, no errors. Good to see. Let me turn this red off. Shaders, visualize. I think it's in the water one. I'll just accept that the water's broken at the moment. But yeah, so if I move right now, this isn't this isn't working. I don't have any world if I move. Only if I resize the zoom, or only if I zoom the camera by like resizing does the world come back. But interestingly, that only happens in OpenGL. So if we go to DirectX, then this works fine. Except I can't see the water anymore. But I'm gonna fix that later because I want to work on this command system that I started to implement. So let me go to the graphics code. Manta, graphics. Yeah, so I have this GFX render command. And so let me think about this. How do I want to test this actually? Let's create a little test project. I think this one's gonna not compile. Oh, it does compile. Great. Okay, cool. I already have a test project. I'm just gonna delete everything from here because this is gonna be my new test project. Let's see though. Yeah. Okay, so we have these render commands. So you can create a command by just, creating this little variable command, and you have to bind a shader to it because this is like defining the pipeline state object essentially. And then, yeah, so the way this works in a few different ways. So you can either execute these commands like immediately through this render command execute function. You got to pass it the command so it knows how to set up like the state internally. But then this takes a function pointer essentially. And you can create one by using a lambda like that if you want to like inline it. So basically what this is doing in the API is it's like this render command describes the graphics state for this draw call or I guess this command work, not really draw call because you can have multiple draw calls. But if I like draw a rectangle in here at like 128, 256, 256, we'll make it red. And then I just run this. It does not work. Why? Why didn't that work? I saw the rectangle for like half a second. OpenGL, does it work? There we go, OpenGL. I'll use OpenGL as my demonstration. See, there's a lot of kinks to work out here. But yeah, we have a red rectangle, and you can create like another one. Do 2 draw calls. A green one. Let's just like offset this guy. Yeah, there we go. Two rectangles, 2 squares. But yeah, this is like the work that this command does, but this executes that immediately. But you might not want that in all cases because maybe you want to sort your draw calls after you've like compiled the list of draw calls that you want to draw. So you have an unsorted list, and then maybe you want to sort them. So what you really want is a way of deferring the work to a separate time when you're going to execute it. So I've implemented that already. So you can instead apply the work to the command. Same way, you just put the lambda here on the command itself, right? And now you can just execute the command at any point in time afterwards. And it executes the work. So this happens later. And the cool thing is you can do this multiple times if you want. So we like do this 4 times. If you go in render doc and actually look at this, we'll see that. Here we go. We have 4 on the left side. We have 4 calls containing each call is like the two quads. We have 4 of them, which is neat. But this is a simple case because the work here that we have basically doesn't have any data associated with it. So like we're just hard coding values. Like this is going to draw at this position with this color. So there's no state with this that determines how this thing is drawing. But you can imagine a situation where there is state. So say we have like, let's get some like positions in here. Well, yeah. And let me get some basic just controls so I can move this around. It's like x minus equals 128 times delta. Super quick code. Bear with me. Oops. And then let's go back to the immediate rendering. I'll have both of these. And I'm kind of going through this as just like my own thought process too. Rambling to myself. Okay, so let's bring this back. Render command, and then we have the lambda expression. Let's offset this by the x and the y basically. Okay, so now as I move the things around with the keyboard, there's state that determines where these things actually draw, right? So it's no longer simple when you cache a draw call, cache work. It's no longer trivial because like now you have to somehow also store the state that it needs to read for the draw call. So this obviously doesn't need to store state because I'm just executing this immediately. And the way this is implemented is it's just a templated function that will take a function pointer and then immediately execute it in the function. So that can work. Now, if we go back to this example, and let me just copy this code over. If I just try to do this, it's not going to work. It's going to, well, actually. It did work. This is a horrible example. How'd that work? That should not have compiled. What? Is it because X and Y are in scope? If I take these out of scope, is that why? Okay, I'm thoroughly confused. Oh, I see what's happening. Okay. Great. Okay, that worked because these are static variables, and as C++ is converting the lambda to a function pointer, it sees that these are static variables and it knows that the pointers to them will never change, so it can stub them in from their addresses, and that's why that was able to work. If I make these local variables though, let me, because that's a special case where that actually worked. I love when things don't work on the demonstration. Okay, here we go. Now we're getting there. Because these are local variables, now this won't work, because an enclosing function, the local variable cannot be referenced in a Lambda body unless it is in the capture list. So if we did a capture like this is how you define a Lambda that takes a capture. This isn't going to compile because basically there's no way you can store a function pointer to a Lambda that takes capture variables, because C++ can't, I guess, convert a Lambda with captures to a function pointer, like a raw function pointer. So the way you would have to solve this is I would have to template this graphics render command with the Lambda expression. Like my Lambda would have to be the function, the expression generated by the Lambda. The template would have to be the expression. And that doesn't work. So instead, what I've done with the API is I still allow you to do this, but you have to specify, you have to basically store it in like a payload, I call it, like an argument payload. So what you would do is you create a struct. So you're basically creating a copy. Yeah, that's true. You can use standard function, but it's doing this internally. That's how it's implemented. So I'm basically doing what standard function does. But yeah, so the way to make this work is you just create a struct that like has the data that you want to actually access in your deferred draw call, right? And then now instead of using, so like here's a Lambda with no captures is what this little plus sign does. I can create a version of this, an instance of this. And then pass it this. See, and now it's not a Vulkan renderer. Not yet. It's coming. Yeah, so basically this works. It's actually OpenGL and DirectX 11 right now. And I have Metal as a work in progress. So Metal is next and then Vulkan. Okay, so this works again as a deferred draw call. Yeah. Yeah, so yeah, you're already stepping ahead of what I'm going to be doing next. Is so the way I'm allocating. Yeah, so basically what this does, if you actually look at the implementation, it's taking in this payload, I call it, whatever data, and then it takes a function pointer, which is like basically a Lambda expression that takes in this argument. But because I don't want to actually template this class itself, because I don't, it's just unnecessary to do that, I can decay the function pointer down into, it's crazy, but I can decay the function pointer down into just a void pointer. Yeah, sorry, I'm reading the chat. Yeah, I decay the function pointer, and then, but what I'm doing what I want to get rid of is right now I'm just allocating memory using malloc for the payload. So basically any command that had a payload, I'm just like mallocing a copy of it, so that when I do the deferred call later, which is wherever that happens, do the execute command down here somewhere. Here we go. Yeah, when it does the deferred execution, it like calls the function pointer with the payload. But it's really stupid to be calling malloc basically for every single draw command, because memory allocation is expensive, and I could instead just have sort of a global stack that I push to. Yeah, I do use C-style stuff. I don't know what PMR is. Or, yeah, I don't know what PMR is. But anyway, I'm just going to implement, rather than having this malloc call, I'm going to implement a system that basically creates a stack for each frame. Because the lifetimes of these commands are like per frame, so I know I'll never like... You can't defer work beyond the current frame, is basically the way I'm going to design it. So, I'm going to create just some class. I'm just going to say GFX. I don't know what to name this thing. I'm just going to call it stack right now, and I'll rename it later, because the name is not actually the important part. So we have data. We have size. We have a capacity, I guess, and we have a current. And we'll make it public, because why not? And this thing will return the offset, because we will store the offset rather than the raw pointer itself. And then I think this is all I need, actually. Oh, I need like a clear function. I need to make my text a little smaller. I'm going cross-eyed reading this. Or maybe like a reset. Oh, let's call it clear, why not? And we need a grow. Okay. So let's just speed run the implementation of this. And let's just put it up here somewhere. I can get rid of all of this. Okay, so we will do some basic error checking. And the trick is when we clear, we just reset current to 0. And when we add to this, we just add, so memory copy from data current payload. What? It's because you can't do that. Here, I won't use void. I'll use my little byte because you can't do pointer arithmetic on a void pointer. Okay. I'm not a big fan of bin, mostly because I forget what's Vim called. I don't like the way the the edit mode works. It's like you have like edit mode and navigation mode. And I know it's just a matter of like kind of brute forcing it for a while until you actually like you get used to it. And I've tried a couple times, but I'm a very point and click kind of person. So yeah, it doesn't work. It doesn't work for me. All right, I think that should work. And then last we need is grow. So I'm just gonna steal the grow from one of my other functions because I've done this a million times and I don't really want to re-implement this. All right. So this is just a simple grow. Where it just doubles size if the capacity is reached. And greater than or equal to. Actually, let me see what my list does. Yeah, it seems to be a while loop. See, it's good to check these things. So this needs to be in add. All right, there we go. A simple stack allocator. Now, instead of using, so we need to create one of these that is global as well. Let me do that real quick. I don't know where a good place to put this is in the file. should also return that. We will chuck this at the top of the file. That was below what? Swap chain init. Frame end. Now, this is going to have problems because this isn't thread safe as well. So that's something that we'll need to think about also. But for now, I'll just start this with an initial capacity of like, well, I'll start it with 1 just to demonstrate. So we initialize, we free, and then frame begin. We just clear this thing. And then, basically every time we need to allocate a payload, we will use the this new API instead. So work payload equals stack dot core.jfx add, and we add the address of this size of t, right? And then we don't need to mem copy anymore. And let's do that for this one. And then payload has to be offset the 0UL. Actually, so I'll know if it's null or not. Or I guess I'll know if it's null if the size is 0. And then when it comes to actually calling this, we need to go into the back end. And just retrieve the pointer, retrieve the data. And this let me clean this up actually. This should be fine for now. Alright, so this in theory should just work, assuming I didn't mess it up, and I certainly did. Because I don't need this anymore. Alright, What's the problem? Segfault classic. Where? Invoke. So yeah, I didn't like that. Just verify that this is a sane value. That looks pretty sane to me. 0 would be exactly where I expect it to be. So why doesn't it like that? I suppose 0 would be the wrong offset if it doesn't have a payload, right? No, we didn't deal with alignment yet. And yeah, that will matter. It's not too picky, but yeah, that will matter. Yeah, because reading, yeah, obviously reading memory that's off alignment is more instructions because it has to like align it with like bit shifts and stuff. It's crazy. Okay, but let's just make sure this works first. So wait, what's the segfault? I need to create a different function here. Can't think. Where is this thing? GFX stack. So we'll add. I'll do like add and get. So we'll get the pointer back from this thing, from an offset. I love these 3-letter long functions that you'll forget what they actually do in like 3 days. Okay. And we can do some assertions here as well. So like if we assert the size is, or offset, obviously the offset needs to be less than the current position because otherwise that's a bad day. I'll say offset size. That's an equal current. So if size 0, then this just must be a null pointer. It's the expectation. And then otherwise. So we can instead do there we go. We have solved the memory problem. Now let's just sanity check that some of these error checking stuff is working. Yeah, great. Now, see, I can stop printing that. If we actually print, so the memory allocations are still happening here because I'm calling realloc and malloc. If I really cared, you could use like a memory page and like commit to it as you go, like an arena style allocator. But this will already grow so infrequently over the lifetime of the program that like it basically doesn't matter. Like we grew 3 times because our initial size is 1, so we had to double a few times to actually grow. But now each frame isn't like reallocating for every single call, which is mission accomplished. But now alignment. That becomes the fun part. So we need to align to the, how does that work? The size, the alignment of the type. I haven't written this in a while. Yeah, because right now our alignment will just be whatever the struct or the current pointer happens to be. But we actually need to increment before we get to that point. So let's see. So basically we need to like grow the buffer if necessary. Write the payload, sure. Yeah, so yeah, it's hard to like, it'll be hard to catch that too, because like the bug with unaligned memory is just that it'll run slowly. It'll just be so much more slow to actually like read from it when you cast back to the type it expects. So how do you align? It's a great question. So like if a struct needs a 16-byte alignment, but you're currently at byte, I don't know. Align of, I guess I need to pass the alignment to this stack when I call to it. So like we need also, I guess we just pass as an integer alignment. So when we use this, which oh, I'm pointing on the right. So align of T, that gives me like the alignment requirements. Let me just verify that this makes sense. I need to sanity check this. So like, because it's a while since I've written this stuff. So like, what's the alignment of double? This thing should be 8, right? 8, yeah. Let's get this visible. Or I guess I could just do a context here. Yeah, all right. Yeah, I spent a lot of time, a lot of time actually like getting the compile to just go, just. Phew. At my old job, when I used to work in AAA, a AAA company, their compilation times were really rough. So when I started this project, one of my priorities was one of my priorities was to have as fast of a compile time as possible. Okay, so I need to basically offset the current to the next interval of my align of is basically how this has to work. How do you even do that is the question. Where am I? Add. Did I pass a line of to both of these? I did not. How did that not error as well? It's like I don't call this function, so I didn't get an error because I'm not using that. Okay. Yeah, I don't use the. Yeah, I've mentioned this on other streams, but one of the compromises I made for compile times was not using the standard library at all. So my code base is very C-like in that respect. Okay, so let's see. Yeah, there's nothing from standard in here at all. It's one of the reasons I can compile the whole project in like half a second. Well, let's do a clean compile. Let's see what I'm actually at. I got all this debug stuff. Yeah, so this is the actual time for the project is half a second. And the total time for the build is a little more than that because I had to do some asset processing as well. Okay, how do I do this? So current needs to I'm sure there's like a bit shift trick to this, but can you do it without one? Like, is the next alignment size? Oh, that's a nice CPU. I have the, what do I have? I've like the 7950, I think. Info. I don't even remember. Yeah, I have the 7950. Just the X, not the X 3D. I did a big PC upgrade about a year and a half ago. So it was actually a game changer because I was rocking some like 9-year-old Intel chip before this. Okay, let me just, this is where I'm gonna cheat. I'm gonna cheat here. Yeah, so the reason I want to do this is, well, the reason I decay them is because I don't want to have to template my base class. It's kind of like the motivation for that. But the reason I'm deferring work at all is because I want to implement a render graph. And my idea is that these commands can be sorted or like you want a way to defer work. Like first, like you create a list of work, and then you might want to sort each one based on some criteria or something, and then you actually like execute the work. So you want a method or a process, a way to defer work. And I didn't want to template my render command class because I just didn't think it was necessary, I guess, because this works. Yeah, and the problem is like when you template this, your template would have to be, I guess, the function, because like what would I be templating if I'm templating my base class? my template would be a function pointer to type T, which is the payload. So like when I template my render command, I guess I would template it to the payload type. And I'm just trying to avoid templates as much as possible. Like I try to keep the code that's like templated as, I guess, small as it can be. I have not, no. I'll preface this that I like just kind of came up with this a couple days ago. So it doesn't go much deeper than that. Like this line of code is kind of insane. Like what is even going on here? Okay, cool. I'll have to read that. Okay. I just had AI get me the general formula for aligning to the next interval of an alignment size. So here we go. Let's see if this works. Oh yeah, you've got the formula. Your formula matches exactly what the AI has given me. Great. Okay, I love that. So, current is, what is value here? Is my current pointer. Yeah, this is like something that like you could probably derive this if you spent the time to actually figure out what the hell it's doing. But like I don't have time to figure this out. Let me think. So yeah. My microphone's messing up. 1 second. Fresh music. My microphone does this weird thing every so often where like, I don't know if it's like the sound driver's breaking or my, something happens, but I get like this crazy static that just like destroys my ears. Okay, so what was I doing? I'm stealing your alignment code here. I guess maybe I would have to assert that my alignment is greater than 1, equal to 1. Even though this should never not be true, I suppose. So and then all right, what'd I miss? Yeah, type erasure. All right, and then I think this code should just work immediately because the size will grow until this is true. And then we're already at current when we get to the next thing. So how do we test this really quickly? Let's just test it up here. So say we're like, let's have like some big buffer. Yeah, so say we like insert something that's size 5, even though I don't even think that's possible. And then we're inserting something that expects alignment 8 afterwards. So this should go to 8. Yeah, great. And then we just add another one. 8, 8, 16. All right, sweet. Alignment is in. Oh, I should make that context sphere actually. Nah, I'll do that another time. Yeah, that's what I was thinking. The offset -1. Nice line. Okay, so, I mean, is that foolproof? Does that just work? So that works for this case. Let's see. Oh yeah, and then I have this little, I don't want to have to write this all the time, so I wrote a little macro to do the same thing here. So like you can do this. And now it's like a little more readable what's going on maybe. I don't know. It's just magic, I guess. Yeah, so, and then the next step of this is I have the render pass. So the GFX render pass. So the render pass can take a render target. So let's create a render target really quickly. I already have one. Okay, so I already have a render target, render texture. So like you bind a texture to it. And then we have to like begin the pass. And then can't type. So anything in here will be part of the render pass. If I go to DirectX, I can also name this. I use Ninja for the build system. So yeah, if you're familiar with what Ninja build is, my build tool just creates these Ninja files. Output, build. They look like this. It's just like, basically just, you create these commands, but like it calls Clang or LLVM or GCC or whatever compiler you're using. And like CMake uses Ninja internally as one of its backends. I guess backends you could say in quotes. It's really easy actually. You just need so I just included it in the project because I decided I didn't want to install it. But it's just like an executable. And all it does is it takes care of like caching the compilation, and I think like scheduling it in an efficient manner, so it uses like multiple threads or whatever. I don't know, it's a bit above me. But yeah, it is cross-platform. If you go to ninjabuild.org, there's more information about it, but you can just get the binaries for it on the GitHub release page. And then, yeah. So if you like ever look at a CMake project, there's like well, it doesn't always use Ninja, but there's a decent chance it does use Ninja. And like if you actually like look in what goes in that like .cmake folder or whatever that it generates, it's possible to find the Ninja file. Okay, where was I? Yeah, so I have these testing, runtime, scene. Yeah, I have this render pass concept. So this, I guess you could consider like your scene graph or your render graph, but not really, it's just a render pass. How come to think of it? I'm trying to think how I want to do this. Let's move this deferred execution into the render pass though. So we like start the pass. We'll render into it. And let's make this thing like the size of our window. And then we'll just draw this thing. We're done. And it does not work because DirectX did not like working. There we go. Yeah, we're not clearing. Here we go. Yeah, so we render to the render pass first, and then draw the render pass. Yeah, let me think. So yeah, what I'm getting at is that the render pass, I guess I modeled this like a render graph initially, because what I did, I'm not sure if I might change this. I'm just kind of coming up with stuff as I go. The idea I had is that you could add commands to the render pass. So like I could give the render pass this command, and then rather than calling like begin end and doing work there, you could like execute the render pass in one go. But now you're not clearing it, so maybe this isn't even a good implementation. Like what I really need is the render graph, which is like another class that can take a list of commands and actually do something with them. So let's create a render graph class. So you have like a render pass, you have a render graph. Let's just copy all of this stuff. So render graph. You can add a command to the render graph as well. And maybe the heuristic associated with the command gets added when you insert to the render graph. Yeah. That's partially why I I did the shader language thing that I wrote, which I don't know if you were here in one of the previous streams where I talked about that. But yeah, that is a problem, and I've thought about it. And I'm still not sure. I don't know. It just gets complicated no matter what you do, I think. But the benefit of the compiler, writing your own compiler, is I can parse information from the shader files themselves to help bridge that gap. Like I know, like from the shader files, I know all of the types that I'm using as uniforms, and from that I can generate the actual, you know, binding sort of boilerplate that you would need to do manually from the shader files. So that was like my main motivation for going this route, is that I think it's possible to bridge that gap, but I'm not, I don't know. I guess I'll see when I actually get to doing it. I go on these little side quests where I like refactor my render in the process. Yeah, yeah, and Spurvy. Yeah, obviously I'm aware of Spurvy as well. And it kind of does this for you, so. But yeah, I'll show off this shader compiler here really quickly. Let me just get this to compile again, because this isn't gonna compile. Okay, so I can go to a better project that has a more complicated shader as well. Okay, so for just I'll do a quick rundown. So the engine, okay, so let's start from the very beginning. I was really annoyed in the beginning about, because I had a game engine before this that I was working on for like I was working on a game engine that was like the game, so it was just like, you know, the engine is the game. So I didn't come into this engine with no basis. But anyway, the way the previous engine worked and how I guess a lot of sort of simple renderers work is if you want to support multiple graphics backends, you need to like write a shader that's GLSL, write one that's HLSL, write one that's metal. So if you have like a bunch of shaders for different things, you'll find yourself writing the same shader multiple times just in each language, because that's the language that the APIs expect. Now, obviously, SPIRV exists nowadays, which you can take like HLSL and cross-compile it to metal, cross-compile it to OpenGL. So that kind of solves that problem. I didn't go that route though, because I decided I wanted to try implementing it myself, essentially. So what I have is my own shader language that you use to actually write the shaders. So this is like, here's the globe renderer that I made as like a demo project for the engine. So this has some complicated shaders. But here's like the atmosphere shader. And the way the shader language is structured is it's kind of like C++. I was inspired by the way metal shaders work, because metal shaders are basically just C++ code. And I forget, they like hook into the Clang compiler or something to actually generate their, you know, bytecode or whatever they do. I don't know. But you can see like, here's my vertex entry point, my vertex main. And then down here is my fragment main. And if this was a compute shader, you would have like a compute main. So they're all just in the same file. And then like for the vertex formats, you basically specify the input and output of each stage. So like the vertex input sort of layout here will define your vertex format. And then for like uniform buffers, there's a similar syntax where you like define the uniform buffer and then, you know, all of your like members here. So this is like, it's just a struct, right? This is what it is. And then, yeah, so you write all your shader code as normal. And then when the engine kicks off a build, as part of like the build process, so when you click build and run, you can see it over here on the right side. There's a part for shaders. I have a compiler that parses the shader code and generates, depending on the backend that you have hooked up. You have, so like here, I have OpenGL that I just ran. This is the shader file in GLSL. So it took the original one and it translated it to GLSL. Now the code looks ugly, right? Because it's not meant to be human readable anymore, really. Because it's like generated HLSL from the shader, the input shader. But if I switch to DirectX and I rebuild, I need to close this first, obviously. It rebuilds. Okay, now we're in DirectX. The same shader file, but now if we go into the generated output, now it's an HLSL file. So you can see like, it's just translating the shader into the back end. But it doesn't just translate, because as I showed before, you have these like uniform buffers and you have these vertex formats. So since I have my own shader compiler and I'm parsing the shader anyway, I can extract this sort of information. Like you can extract information from the shader file to aid with other stuff in the engine backend. So alongside the outputted, like the output translated shader code, I also generate some other sort of boilerplate stuff in this file. Where is it? Objects, graphics, here we go. So like here are all the, here we go. Let's look. And I have a bunch of debug stuff being generated too. But like here's a struct that I've generated to exactly match the alignment in like format of this uniform buffer here in the shader. So like when you want to create a new uniform buffer, the only place you have to write it in theory is in the shader file that actually uses it. And then from this file, it will generate a C++, I guess, hook that you can use to actually like, I don't know, write data to and from, I guess, to the graphics card. And this is complicated because it's more annoying than you would hope. Because for instance, and I learned this through just the trial and error, in OpenGL, when you have a uniform buffer, let's go to the generated shader code. So where is this uniform buffer? So you have this uniform thing, and here it is. Here's the uniforms. You specify layout, and this is STID 140. So this is like a standard memory layout for the fields, like the members of this uniform struct thing, which specifies the alignment rules for how obviously these things get laid out in memory. And that makes sense. Great, there's a standard, right? Well, DirectX doesn't follow the same alignment rules. So like, if you look at the DirectX code, you get the same buffer, same struct, but the actual alignment of the members can be different because of how the two APIs align their their structs, which becomes a real pain in the ass. So, but I figured that out, at least for OpenGL and DirectX, and I generate the appropriate padding for these guys when I generate the little struct. Yeah. Time to switch, I know. Yeah, well, I think DirectX 12 actually complies with STID 140, and Vulkan does as well. So thankfully, I think it's like, it's easy. But anyway, what's cool about this is that like the actual user experience of writing code for the engine, like here, let's compile this shader. So here's like the composite shader, which basically takes all my intermediate render targets and composites them onto the swap chain. I can just add a new uniform buffer here and like bind it to slot 1 and call it like uniforms color. And it takes in a float for color. And then the language requires me to pass it as an argument. This is because metal code expects everything to be passed as arguments. So I kind of looked ahead on that a little bit. Because like, I don't know, uniforms. If we just multiply this. All right, then we build. So now we have access to this thing. So if we could like go back here just as a demonstration. Here we go, uniforms color. Here's our little uniform thing. So if I go in the actual game code here, I can just edit this thing live. Like I have access to the uniform buffer now. Here's the color one, the color. We can make this like red. And then I can upload this. So you have to actually send it back over. So now the world is red. And then like I can come out here and make like a color. Hook it up to the console as a variable. And then we'll use this instead. And now it's like, if I want a color, it just immediately works. And that's like, there we go, DirectX. OpenGL. It all just works. It's magic once it works. So yeah, it's a lot of work to actually get to this point though. But once it's working, it's actually really nice. And the vertex formats work the same way. Like if I want to create a vertex buffer, So I create like a vertex buffer. I can just use the vertices from my shaders. Like, here's the vertex globe. So this guy is just a vertex format, but if I go into the shader, I think it comes from this one. So that's generated from this. So you like specify vertex formats and you just have access to these immediately. So if you have like if you're rendering something that has like a very specific packed vertex format, it's just easy to actually write shader code and then use it in the engine. And then, yeah, you asked the question, how do I actually do the parsing? Yeah, it's pretty simple actually. If I go to the build tool, basically it's like a scanner that takes an input string, steps through it, you know, token by token, and then from the tokens there's the parser. So you have a scanner that can step token by token, and then the parser, which uses the scanner to like interpret the tokens and generate nodes from them. So this is like a syntax tree type compiler, I guess. So like, I don't know, where do I have nodes? There's a lot of code in here. Essentially, it generates a bunch of nodes, and the nodes can be like an expression. So an expression is like, you know, addition of a left-hand side plus a right-hand side, or like a condition, like a ternary expression is like, you know, like this guy, if condition, true, false. Like this is a whole node. And the parser basically can figure out if the tokens represent one of these or not. I'm not a compiler expert, really, so I'm probably doing a bad job explaining. But actually generating the output code is just a matter of stepping through the syntax tree, the node tree that you've generated, and then outputting like, in my case, I'm just outputting text in either HLSL or GLSL. Like here's an example. Let's see. I'm trying to look at an example where yeah, if I'm reading this right, I guess HLSL calls saturate, whereas in GLSL it's clamp. So like I have this intrinsic function in my language that is just called saturate, and then when I'm generating HLSL or GLSL code, I need to stub it in with clamp instead of saturate, because saturate just clamps it between 0 and 1. And the whole source is up. I don't know if the link is on the Twitch account actually, but I have the source up for this on the GitHub page. So you're free to look at it if you want to. But anyway, that's that was supposed to be a brief rundown, but I went rambling for 20 minutes. All right. I was working on the render graph. Yeah, no problem. I'm glad that at least some people find it interesting. It was a lot of work, and I questioned whether I was a sane choice to do it, but it was insightful, I think, in the very least. All right. So the render graph has a list of commands, and what else? remove this from the render pass because that doesn't really make much sense to have that there. What's happening? My phone's vibrating. Okay. So hey, how's it going? I am working on rendering code. Working on, well, a few different things. I've been jumping around. I'm working on basically render passes, render commands, and a render graph, which kind of combines, I guess, the two of those into one higher level abstraction. And if you don't know anything about graphics, that probably doesn't mean anything to you. So in short, I'm just working on a way of organizing how I render stuff. Okay, so let's see. I need this function. I guess it doesn't need anything there, doesn't need anything there. Well, it is a game engine, actually. It's more than just a rendering engine, because I actually have some games in progress. But yeah, basically. Unfortunately, rendering is such a big part of game engines that it's like most of my time is spent on the rendering, because it just never ends. All right, I don't have a name for this. It doesn't really make sense to have a name for the render command. Get rid of these temp labels because it's obvious. All right, cool. And then, did I delete targets on accident? Where's my render graph? I need to keep those. Okay. I think this should compile again. Oh yeah, I can get rid of this testing code, this demo code. The reason the why is because it's fun. There's nothing else beyond that. You know, if I were doing this as like a job or as a money-making endeavor, you have a great point. But I just like having fun programming, so I already have a full-time job and I make plenty of money, so it's purely for fun. It's a hobby, you know. Some people take things way too seriously. I know it's a lame answer, but it's the truth. All right. I mean, okay, if I were to answer that question genuinely, well, that was genuine before, but I can't answer that question in things that I'm making in the engine that aren't in other engines. And like the first one is that it builds really fast. So like, look, here's a clean build of the project. With assets, like it's like compiling, it's like building the assets, it's generating the bitmaps, it's compiling all the code. I literally just built the whole project in like a second and a half. And I can rapidly iterate. I don't know why the lights just went off. I'm like in the dark now. So that's one thing. Is I care about code that has quick turnaround times, because I actually have industry experience where I've worked at a AAA company that had their own engine, and the turnaround time between changing code and actually having the compilation finish and the game up and running was like several minutes to like half an hour. And I'm not even lying. Like, I'm not even joking. It was literally that bad. Now, obviously, some of the more commercial engines like Unity and Unreal, you know, the public-facing ones, are a bit better than that. Kind of out of necessity because no one would use something that takes that long. But they're still really clunky, right? Like, they still are clunky. So because I like programming, I have fun designing an engine that doesn't have all the clunk. Now, if you're fine just sitting around all the time, that's perfectly okay. So that's one. The other is that it has like no dependencies. So I have full control over like how big the game's executable is, how the data is, you know, compressed. Yeah, so I could rant for a while. But ultimately, the main reason, the cheesy reason, is that it's just fun. Like, I have the whole source up on the GitHub page. Like, I'm not making a product or anything. Okay, so I have the render graph. But yeah, here's my, this isn't a game really, this is just like a little demo. But here's the little earth thing I did last week. You can't go in too close to the, oh, I've actually fixed the bug without even trying. Look at that, it's crazy. You can't get too close to the atmosphere, otherwise it looks kind of bad. I would show off the other game, but unfortunately things are kind of busted right now, so maybe I shouldn't do that. I can show a YouTube video of it instead. But I'm going to finish this first. Okay, render command. So a command is just a collection, a graph is just a collection of commands. Where is my project? Yeah. No, like, I should preface, like, I before making game engines myself, I used game engines. So, like, the vast majority of my time is using real engines. I find the deeper down the rabbit hole I get, though, the more I enjoy making the engine over the game. But, yeah. Okay, losing my train of thought. Test, here we go. Here's my test project. So this won't compile now. Well, here's the other game. I'll preface that it's broken right now. Oh, it really is broken. Okay. I didn't think it was like broken to the point it wouldn't compile. But it really is broken. What? Cannot convert from const t pointer to void pointer. I mean, I guess that makes sense, doesn't it? Oh, that's annoying. How is that okay with mem copy though? I just mem copied that before. What do I use there? Is it because that's not const? Void. Okay. Void pointer. Wait a minute. Yeah, it is void. Okay. It is const. Yeah, you have to preserve your constant correctness, otherwise it doesn't like you. Not really. I've been streaming more the last few weeks. I've usually been streaming on Sundays. Yeah, so here's the other project, which is a Terraria clone, basically. Now, it's not working because you can't see the water, because I've broken the rendering. Maybe I can find a build that actually works. Um, or a video of it. Here's what the water is supposed to look like, but I've currently broken the game, so, or the engine, so the water isn't rendering anymore. But it has cool water physics, and I'm proud of the water physics, so I'm gonna show it off. You got like, and there's lava too. You got lava physics. You can control the water like magic. All right, yeah, that's what the other game looks like. Okay, let's see. But I decided this past week, for context, that the way I was doing my rendering abstraction layer was, I wasn't thinking very forward towards the future when I was doing it. So I'm changing it now, and I'm improving it. Yeah, thanks. It's certainly complicated, the engine stuff and like the low level stuff, but I'll also say it's not as complicated as it seems. Like there's like a lot of just repeating patterns of how you do stuff. So like it seems complicated, but like ultimately what you do is you're just moving memory around. Like you have data in one format, you want to represent it in a different format, or it's like you need to just like represent some concept somehow. So it's like, well, how do you store the information about this thing to actually like do anything with it? And that's like what basically every problem is when you do low level sort of programming. It's just like here, this looks like like a bunch of crazy stuff, but like it's literally just like copying memory around in a safe way. And these patterns show up all the time, so it's not, I don't know. I just think it looks more complicated than it is, and it doesn't help that the syntax is a bit verbose with how you represent ideas. Okay, so, but yeah, I'm working on this stack, or this render graph system. Yeah, sorry, I know it's kind of small. I don't know if that's better. It's big on my screen is the problem, so it's like I need to find the happy balance. I think this can work for me though. I guess, yeah, since some new people have joined, and I'm going to be streaming for at least another hour or so, I can explain generally the philosophy behind how the new renderer works. And then, oh, my eyes. Okay, I have to turn this down. Let's get like a nice dark gray color. I'm like burning my retinas. Maybe that's too gray. Okay, so basically the way rendering works is you have draw calls, right? And this might be super simple if you know what that is already. But you have a draw call. So this is like, I don't know, draw X number of triangles, right? Triangles, if I can type. Or like, I don't know, draw this mesh, this model. This is super simple terms, right? You're telling the graphics card to actually do something, a draw call. Now, that tells the graphics card, you know, how many vertices are there? How many times do you want to instance this thing if you want to like duplicate it? What is the format of those vertices? That's a draw call. And the CPU is always talking to the graphics card. Yeah, that's an interesting question. Because the answer to that is I don't do it well because I keep going back and rewriting stuff. But I think like every time I go back, I'm more informed about how the design, I guess, quote unquote, should be. That like I get closer to a a good architecture. That's okay. It's all cool. But anyway, you can think of these draw calls as like a little packet of work that you send to the graphics card. So if, for instance, I can demonstrate this by going to the globe project and doing render doc. So here's a graphics capture tool called render doc. And it's probably hard to see because I can't make the text bigger. But there's a call here, if you can't read this, that says GL draw elements. So this is a draw call for OpenGL backend. And basically the draw call was for the mesh that makes up the earth in this example, this little project. So here's like the actual mesh of the sphere, right? So this draw call submitted that sphere, and then the graphics card drew it. And like there's draw calls for a lot of stuff. Like here's the draw call for, I don't even know. The sky should be in here too somewhere. Here we go. Here's like the stars in the background. If I like look at the mesh, it's like I'm drawing the stars as just a texture on a sphere. But that's draw calls. So around a draw call is what's called the pipeline state. So like in black, I'll say the pipeline state. And this is like graphics card jargon. So you have like the pipeline state. So this is like, what is the depth test mode? Depth testing. You have blend modes. You have, I guess, raster state. So like culling, etc. Like fill mode. And this is just like things that the graphics card can do for you. They're like built in, but basically you have draw calls that like actually tell the graphics card to, hey, do some work, draw some triangles. But as the graphics card is actually drawing the triangles, it needs to know like how to draw them. And that's kind of what the pipeline state determines for you. So like if I go back to this OpenGL example, for this draw call for the stars, in here, if I expand this, I click this and it expands down here. Again, probably hard to see because the text is small. But there's a lot of stuff happening here to like configure additional state. And most of this is configuring the pipeline state. Duty. Yeah, exactly. Freudian slip. Do for you. Yeah, but anyway, that's a pipeline state. So a modern renderer basically juggles around. When you render a bunch of stuff, it's like you have, if you have a, like, I don't know, I'm trying to like explain this in a simple way. Basically, you have these pipeline states that determine how stuff should be drawn, and then you have your draw calls that like tell you how to draw triangles. You have resource, I guess, binding, which is also kind of in the, I guess, somewhat tangential to a draw call. So this is like setting a texture or like uploading uniform data for shaders to use for like, I don't know, it just gets complicated. But the overview of what I kind of decided this week was that my graphics code wasn't really thinking in this sort of way, where there's like these abstraction levels between work, which is like a draw call is like considered work, or a command, I guess, and then like the pipeline state. And then you have like, like even outside the pipeline state, you have a render pass, which determines like where the pixels that are being like rasterized actually end up in memory. So you'll have like, I guess it's kind of parallel to this. You might have like a separate render pass, which has different render targets. I don't know. My diagram is falling apart. But basically, what I'm working on right now is what's called a scene graph, or a render graph, which basically takes in these little packets of work. So like you can imagine each of these black squares is like a pipeline state with maybe a list of draw calls within it. And we have a scene graph, a render graph that, I don't know, render graph. It will basically have a list of these things. Each of these are like little, I don't know, work, you know, it's like work, bunch of work. And what the render graph is responsible of doing is basically ordering the little packets of work in the most efficient way for like the underlying, I guess, state management of the graphics card. Because you basically want to reduce the amount of communication to and from the graphics card. You want to reduce the amount of state changes that the graphics card's like doing between work. And this gets complicated in a 3D game, for instance, where you have a lot of different, like many different models with many different materials on them, different textures. And they're at different distances. So like if you have transparent stuff, like you need to sort the objects. So like the stuff closest to you actually draws in the right order. So you have like this really complicated scene that you basically end up having to manage. And you have to, you need a way of taking like individual calls of like, hey, I need to draw a tree here and like a pane of glass over here and like a bush here, and converting that scene into an efficient list of work for the graphics card to churn through. So the tricky part then when you're designing an engine is like, or at least in my case, is that my engine isn't specifically a 3D renderer or a 2D renderer. It's just like an engine that should be able to do both, depending on if you want to do either one. So what I'm writing is like, yeah, they can. Yeah, exactly. That's another, it gets very complicated. Because like, yeah, in a modern like AAA game, the render graph typically is, well, it depends how it's implemented. Like generally, like when you traverse the scene and like build the render graph, like you submit nodes to it, you can do that in parallel, because that's a trivially parallelizable problem. Like you just have like a data structure that, or it doesn't even need to have a data structure that can like handle multi-threaded inputs, because you could have just a duplicate one on each thread and then combine them at the end. But yeah, it gets it gets very complicated, I guess. So maybe what I said before about how it's simple isn't necessarily true. Yeah, so I'm working on this in this very moment. So that's what this code is ultimately going to do. Yeah, and if you look up like, there's better diagrams online, like render graph. Like Unity has a render graph. They just call it a render graph. Sometimes it's called a scene graph, or I don't know. People call it like a million different things, but like basically every modern engine implements this, because it's like the data structure you need to implement in order to actually solve this problem. But I'm going to work on it now. I'm going to stop yapping away. I'm going to start actually getting stuff done. Okay, so I have the render graph somewhere. Well, I think this should work already. Let me just test this. Or it should work in the sense that I can submit commands to this thing. So let's create underpass begin. Yeah, so, okay, now that I'm in the actual code now, I can kind of show how this abstraction actually works. So like, here is a render command. So this little structure, this render command, is you bind a shader to it, You can also set like, I don't know, the blend mode. Like, what is the blend mode for the color, right? It takes in different blend modes. It takes in like depth testing, like is like the depth buffer enabled, or you want to do depth testing. All of that in my little abstraction layer lives on this render command. And then in addition to the state for like the render state, you can submit work to the command. So in this case, this render command, its work is just drawing two rectangles. So these are like your draw calls to draw two rectangles. And then the render pass, I guess you can kind of ignore this for now. This was just demonstrating that you can render to like, I don't know, render to textures that aren't the screen, because that's a useful thing to be able to do in game, like in the game engine. So that's what this is. So like I can get this to render by doing render command execute command. If I run this, wrong project. So you can see that like I'm rendering two squares, but we're getting some crazy snake action because I'm not clearing. Delete this as well. We're not like clearing the color during the render pass. So like we clear the color. Now it's like, here we go, we can see the two squares. Now I've just added this GFX render graph. So like here's your graph. Now the cool thing about the graph is that you can add these commands, these render commands to the graph. And then I guess let me make two of these, like command 0, just so that there's like multiple things going on the screen at once. No, you're spot on. I actually I explained this earlier on the stream, but you weren't here. But that's what this little thing is allowing us to do, is that we can have state that isn't just rectangles. You can basically have work that has state that's more than just like what's in this scope here. So yeah, that's implemented, and I actually just finished getting that to work. And now I'm moving on to the next the next step, which is the render graph. So let me make two of these as just a demonstration. So the second one will just draw like a yellow circle or something. I don't know. Just drawing random stuff at different offsets, just as like an example. Yeah. Yeah, so here is a second command, and if I get rid of this and draw both of these, we should see both of them, hopefully. And we don't, because what did I miss? We have a redefinition. Can pull this out here, I guess. Okay, here we go. Now we have two commands. The first one was drawing the two rectangles, and the second command is doing the circle. But you can see, like, if I don't execute the circle command, you're not going to see it. Now, the cool thing with the render graph is you can submit commands to the graph. And then, rather than executing the commands directly, we can execute the graph. Render graph execute. So we execute this guy. And now we see everything. So it's like we've deferred through this graph. Now, the powerful part about doing this is that the render graph basically just stores the commands in a list. So like you just add a command, it adds it to the list. But if we wanted to, prior to actually executing the graph, we could resort the list based on any criteria we would want. And yeah, so in the criteria where you sort can be like a simple case would be like you want to draw things sorted by distance. No, I can't do that yet because I need to finish actually implementing this. But the idea is that you could add a command and then some like heuristic that you could use to sort. And then, yeah, sort the list based on whatever sorting logic you want to use. A more complicated render graph would sort not only by distance, but also try to keep things that are similar. I guess like drawing in sequence to each other, so you minimize the amount of state change under the hood of the graphics card or of the API, I guess. So like your sort criteria could be as complicated as you want, but the cool thing is that basically with this simple abstraction, it's then up to the game that you program how you want to implement that sorting function. So like my engine, as just an engine, doesn't, explicitly tell you how your draw calls should be sorted. It gives you the option to to customize the sorting in any way you want. So yeah, it's like general purpose in that sense, is the idea. Because like if one of my games is a open world 3D renderer, obviously I will have a render graph that has a sorting algorithm that will, attempt to sort the graph in the most efficient way for rendering a giant 3D, open world scene. Now, I'm actually not sure how I want to do this because, well, I know how I want to do this. I think sorting by distance is a kind of like the most common thing to do, because like generally it's easy to sort, or it's more efficient to render things sorted, I guess, front to back for various reasons. So I'm basically unsure how I want to I'm trying to think of like what data do I actually put in these base, like this render command, what data does this thing actually have like on it as like a struct, versus like what data should be like determined by the game, right? Like should my render command struct, like class, should this have like a distance field on it, like distance. I actually think it shouldn't, to be honest. Because it should be up to the game, like what the actual like what sort of payload a render command has that you could sort it with. Okay, I'm going to go that route. So basically, like, rather than having one option is you have like a set distance here, right? And that's intuitive, I guess. Like, okay, this thing is like 150 units away from me. But I'm trying to think, like, if you want to sort on more than just distance, like you also want to store like, hey, this thing is a transparent object. Like, is it transparent? Yes. It is transparent. True. Obviously, this is a redundant equation, but just for clarity, it's like you might want more than just distance. You might want, like, is it transparent? Is it, I don't know. Is it an interactable thing versus not? Maybe you want to like sort them based on some other thing. Maybe you want to filter them based on some criteria. You know, maybe there's a filter option as well as sort. Yeah, I don't have more modern references either. I kind of wing things a lot of the time. I'll say that. Here, one second. I'm going to turn my light back on. I don't know why I'm like sitting in the dark. One second. I'm like a creeper just sitting here in the dark. Yeah, I kind of wing things, if you can't tell. So, I don't know. I would be interested in those links, actually, or the titles, because this is an interesting topic. Okay, I think I'm going to go ahead with the more general way, which means I'm going to like set like, I don't even know what to call it. Would it be like payload? I don't know, like you have work and then you have, or like metadata maybe? Like you set the metadata for a render command. And this will utilize the same sort of like meta payload offset. So this will use the same thing. And eventually I want to actually like shrink this struct because I'm carrying a lot of data here. So let's add a function on here. Unfortunately, another templated one. Let's just copy this guy. And delete that comment for now, because I don't know what the usage is. Yeah, exactly. Yeah, like, exactly. You can imagine there's a lot of cases where transparency doesn't matter and you want to know other things. So you need a way of tagging. It's like you're essentially tagging these commands with some extra, payload of data, and that can be whatever you want it to be. So let's see. We need 2 of these, unfortunately, because of move semantics in C++. I don't know if I should support move semantics, honestly. I'm not going to right now. I'll just do these for now. The basic copy. Okay, and then I can conveniently reuse the same stack, but I might use a separate stack so that it's not as fragmented. Yeah, I'm gonna create a couple different stacks. Well, I'll use this stack for now, but I probably want one that's separate for the metadata. Okay, so now, and then you want a way of getting the metadata back from this thing as well. So I'll be like set metadata maybe, and then get metadata will return a reference to this, a const reference maybe. or maybe just a reference. Be up to the implementer, whether it's const or not. So we get the metadata. So this should be a pointer because it might be null pointer. All right, yeah, this should work. So let's see. So let's test this with just a distance for now. Metadata. Maybe I'll change the name of this. No function. So we'll give it a double for now. We'll do we'll give this guy 1 because we're gonna test the basic case of sorting. And then this guy will be I guess we'll do 2 and 1 because we'll sort it nearest to furthest, so the order should flip when we actually execute these things. And I will print as well, just so it's easy to see the order is changing. All right, and then I just realized this is actually more complicated than I thought. I guess it'll be really up to the programmer of if you're yeah, you have to program that as well. When you draw the thing, you have to calculate the distance and then add that to the command so that later, because it's cheap. It's really cheap to calculate the distance. Well, not really cheap, but it's cheap to calculate the distance. It's expensive to sort. And come to think of it, I'm sure there are algorithms that can actually sort as it goes. Yeah, I don't know. There's probably a million ways to solve these problems. Okay, let's think. Well, let me just make sure this compiles and doesn't error. All right, and I will print some new lines here so we can actually see the order that these are executing in. Yeah, so right now we see the first one, then we see the second one. And if this works in the end, we should see that flip. But we need to actually write the sorting stuff. So we need I don't know. We need a function like this that's sort. Sort, you give it a graph. And then we need to think about how to actually sort the thing. I'm trying to think what I want this API to actually look like. Because I guess when you sort two things, you'll have two functions. You'll You'll have an A and a B. You'll have two things, and you're comparing them. That's what a sort algorithm does. So like, let's just use a lambda for now. So we have like this lambda expression, and it will take a, I guess, a void pointer. The problem I just realized with this is that like each command can have its own, like maybe I'm overly abstracting this. I guess my engine would know, like if I'm adding metadata to draw commands is like, as I'm traversing my scene, if the metadata format between the draw commands changes, like is different, then like you fundamentally messed up your like your implementation of actually using this thing. The lambda. Yeah, the lambda expression is like basically just a function that you can kind of just create out of thin air. So like here, I can show an example of the lambda expression. It's kind of cool actually. So like you can, this is like the traditional way of writing one, is you have like an auto, and then you have like some lambda expression, and then equals. So it's a variable, right? This is a variable, but it's a function. So like here's the scope of this variable function, and I can like print here just to show that it works. Lambda, right? And you can call this thing like a function. So here it is, running each frame here. But the cool thing is about the lambda is that like it can read variables that aren't like in its scope. So like it can capture variables from the scope in which you're like defining this thing. So like this X is out here, but if I print this, you have to capture the X. So you either like write it here, I think, like here. Now I've captured X from the outer scope, and it doesn't like that because I've already used X. Let me say variable var. See, it captured the variable 5 from out here. Otherwise, you have to pass it in like a typical function, like typical parameter, like this. But the cool thing is you can automate this. So like, and a lot of this is just pure syntax sugar from C++. But like if you use the equal sign here inside this little closed bracket thing, then basically what you're telling the compiler to do is like, anywhere where you see me trying to use something from the outer scope, just like infer that that's what my intention is. And the cool thing about the lambdas is that they can decay into function pointers, and you can store them in variables. So like, I can just quickly basically create a function on the fly, like add a call site of some other function, and it will still work as like a valid function call that kind of exists in your code base. And there's some technicalities behind when it doesn't work like that. So it's not like pure magic, but it's kind of a cool concept. Yeah. The cool thing is it's a function that you can call elsewhere. So like you can store it in a variable and then call it some other time. So it's a really powerful tool actually. But anyway, my sort function will take a lambda, which represents what my sorting function is. And the input to the sorting function will be, I guess, meta A and then like a pointer to meta B. Maybe I make this not a pointer. Maybe I can template this, I suppose. I don't know. Doesn't matter, I guess. And then like if I want to get this back as an actual value, you'd be like double distance A equals, since I know the metadata for my commands here will always be a double, you know that this is a safe thing to do. You can, this is where the syntax just gets crazy, but you can reinterpret this void pointer as a double. And then your comparison function would be like, is distance A less than distance B? So this thing would return, this little arrow syntax is its return value. So yeah, this looks like a mess, but it's kind of cool because you can quickly define a sorting function that takes in some metadata payload from one of the elements and another, and then interpret it into the actual thing you care about, and then do a test on that, and then return a value. So I need to actually implement this function because it doesn't exist. I've just been sketching this out. So next to this guy, we'll have like void, gfx, render, graph, sort. And we take the graph, and then we also have a Boolean pointer to sort, which also takes a void, meta A, meta B, and it doesn't like that because I'm in the wrong spot. Should be in the header file. Okay. This should be over here. All right, and now if I wrote that correctly, this, yeah, here we go. So this lambda is not erroring anymore, which means that I actually wrote some valid code here. Now you'd want to be like, you'd want to verify the state of these things. Like if you try to reinterpret cast a null pointer into a double, then like that's gonna obviously cause a problem. So like, I just like to assert everywhere, basically. And I guess to explain what an assert is. So C++ is cool because you can use the preprocessor, these pound define things, to basically conditionally compile code in or out of your executable, depending on whether these flags are true or false. So it's like this separate little process that runs over your code source files before the compiler sees it, that can like basically add or remove extra text from the file. Like you have to like picture this as like actually a text file. But these asserts are like a little macro that only compiles in if I'm on a debug build. So like it does add some performance costs to be checking stuff all the time, especially if you know like if everything's going right, you should never actually fail any of these conditions. But it's powerful to be able to like actually have all this sort of error checking built into like a debug build, so that you can catch these errors if they exist while you're in a debug build. and then hopefully fix them so that they'll never happen in a release build. And then your release build won't have any of these checks compiled in, so it'll be like significantly faster. Okay, so now I need to actually implement this sorting algorithm, but I already have a sorting algorithm somewhere else, so I need to find it. I don't even know where I do it though. Sort. Quick sort. Here we go. I have sort. I have quick sort. So I need to implement quick sort. Let's see. I already have this on the list, actually. Wait, this makes my life so much easier. What is left and right? How do I use this? Quick sort. Where do I call this thing from? Sort. Oh, this is so convenient. I actually already have this implemented. Okay, I forgot I did this. All right, I'm excited. I think this might just work immediately. Almost immediately. Maybe not. I might need to implement this, actually, in hindsight. Let's just implement it from scratch. Okay, let me think. So we need... I made the text super small again, my bad. I keep resizing things. Okay, so I need quick sort. I need the ones that have the compare on them. So I need partition. I need this function. Let me just steal some of these from elsewhere. And I need partition, which is this one. And what else? I need swap. I think I can just use the existing swap though. Yeah, so I can make these lambdas in here actually. Should make my life easier. I jinxed it and then I realized it wasn't going to work immediately. Okay, so my comparison function is this. I'll say compare is the function name. So my comp function is this. And then I can delete the template. Auto. Quicksort equals no captures. And then we need to put partition. Oops. Yeah, we need sort as well. I guess sort is the function. All right. So if graph.commands.current is less than 1, quicksort will take that, and then we will pass our compare function. Why doesn't it like this? Semicolons. I guess we can capture, why not? All right, what's it mad about? An enclosing function local variable cannot be referenced in line. Okay, I'll just make these static functions. I'm getting ahead of myself. Why isn't it like this? Because it's not in namespace. Does quicksort return something? No, void. All right, here we go. We can copy this into there. Copy this into there. Delete all this. Pass it to quicksort. Graph. Yeah, this is as intense as it gets, really. It is I remember I said earlier it's not complicated, but I guess I lied. I'm just used to the insanity that is whatever the heck this is, you know. Okay, compare, everywhere I call compare, it's just there. So we swap the commands. Oh, I don't expose this function? What? This should be public. I'm just gonna make this public. Doesn't matter if it's not public. Okay. Okay, so pivot is a GFX render command. I guess my pivot is actually a void pointer. GFX stack dot where is dot get, so we will get the payload from this guy, payload offset, and the size of this guy. So that's our pivot point, and then we need element. So we compare the left to the right, basically. And then we graph.commands.swap. Doesn't like swap. Certainly does have a member named swap. That's a lie. And this should go there. And then graph. I think it's supposed to be partition. Now we watch this blow up in our face as we actually try to run it. I need to figure out why it's not liking this. Just a fake error. No, it's not a fake error. Oh, it's because it's const. I guess, yeah, sort can't be a const graph because it's actually mutating this graph. Okay. All right. In theory, this should work first try, but it's not going to because it never does. Never does. All right, but what is the actual problem? So meta a equals null pointer. Oh, I'm asserting that it's null pointer. It should not be null pointer. Okay, this was not a fair test because my assertion was, I messed up my assertion case. It should be not equals. My error handling is what caught me. All right, now here's a real here's a real example case. All right, so that is null pointer. All right, let's find out why that is. Okay, so we call this guy if we have no data in the graph, then that's an error. If we have only one element or 0 or none, we don't sort anything because obviously that makes no sense. Otherwise, we enter the quicksort algorithm, which starts at, make sure these are long integers, onside longs. We pass our comparison function. And then the pivot index is, I guess let me make sure I actually copied the partition function correct. Partition. So what is T in this case? T is the element type. Okay. Which, yeah, isn't what we want here. Just make sure this is actually 1 for 1, because I know my sorting algorithm works in its true form. So we get a void pointer, graph.commands.data .write, the payload offset, and the payload size, and that should return a pointer. And then it gets the left elements, payload offset, and size, and then it compares left to right. And then if that's true, it swaps left and right, and then it increments. And then it swaps again. Okay, I think that is correct. So is my partition function, or is my quicksort wrong? So here we go. Let's copy this guy. Compare, let's make sure we haven't made any dumb errors. So left, square to right, return, partition, left to right, compare. Pivot index is correct. Pivot index -1, LLU. All right, yeah, thanks for stopping by. I appreciate the the conversation. It's fun. And thanks for the subscription. Always appreciate it. I might stream again on Sunday, so if you're doing anything Sunday, you might find me again. Okay, so sort. I'm actually surprised this didn't work on the first try. Yeah. It's never too late. The cheesy is never too late. Okay, sort. Where's my actual sort function? Yeah, I have more time on Sunday. I wasn't even gonna stream this evening, but then I was feeling in the mood of doing it. Okay, sort. Current. I'm actually not sure what's going on here. This looks correct to me. I'm not sure how that would become. Oh, obviously, this is just correct. Here I am, like, chasing down. Sorry, I'm like screaming to the mic. Here I am chasing down. Here's the problem. I typoed. Look, I'm setting the metadata, like the metadata here, for command 0, and then I was reusing command 0 right here. So command 1 never got any data. And in fact, that assertion should have told me that, but I didn't trust the code I wrote to be correct on the first try. Okay, did it work? I don't even know if it worked. So command 1 entered first, one before. See if we flip the sign of this. Yeah, there we go. They're sorted. That's exciting. Yeah, so get would return null pointer if the only case it would return null pointer is if you never set any metadata on a command, which is exactly what happened. All right, that's exciting that this kind of worked. I wish I had like a 3D scene to actually test this with. Maybe I can whip one together because that could be exciting. To actually see it in a real use case, because this is disgusting. But first I need to do some extra cleanup because you might also want a filter function that filters out commands. So unfortunately, that's another function we will write. But for now, I will just keep sorting. Because like you might want to filter for like frustum culling as well, or well, I guess frustum culling you would determine that before you submitted it to the scene graph probably. But I don't know, maybe you'd want to filter. That's for some reason. It's good to have that ability. All right, let's make a little let's do a little test. We'll do the classic test where we render transparent objects and then we sort versus not sorting. So I'm in my little debug graphics test project. I mean, I know this is going to work, but it's cool to see it like actually in a situation where you would use it for real. So let's see. I don't know. Testing. Where am I? Anarchy. We'll just up here. We will create actually, I need to look at something first, because now I'm slightly confused. Oh yeah, because I was doing those in scope. Okay. All right, so we need a couple things. We need a little vertex buffer. I'm just going to do the classic rendering transparent glass panes example, because that always breaks if you don't do it right. So like static vertex buffer. I can make the code a little bigger as well. Let's just Let's initialize this guy. And remember, what's the winding order for a triangle? I have this somewhere. Here, I need this winding order. So if I'm doing this between Y and Z, I guess, 0, 0, 0, 1, 1, 0, 1, 1. Sure. And then, so that should be like the most basic. Let's draw the scene. Where do I draw it? Here, I guess. Do it like right here. The triangle strip. It's probably gonna be hard to actually find this thing, but it should render now on the ground somewhere, in theory. Here it is. This is my pane of glass, which is really tiny. But the cool thing is we can create a bunch of these now. We'll do like 500 of them. So we will. Let's create a random. To pull from, and then we need a. Where do I draw the little test ball thing? I want to transform this thing. So I need all of this crazy code. I guess I don't really need rotation, but I'll keep it in, I suppose. What do you mean, no instance? What? What's happening? Let's just make sure this code works. I should draw like 500 of these things. It's drawing circles. I don't need it to be drawing circles. It needs to be drawing my little glass pane. Here we go. Rendering a pane, but it has no transparency. And maybe it should have a random color too. What should I think about? Let me just make a shader for this. Where are my shaders? All right, now we just need to give this thing a color. Let's build that. Shader glass. Leave white for now, it's just a test. All right, my glass panes are white. Let me turn off some of this other debug stuff that's drawing. I don't need this right now. I'm partially curious to see how fast this will sort things as well. Okay, so almost to the point where we have something working. It's crazy I have to specify a max. 360. Oh, I guess this isn't temporally stable because of the cylinder. Let me reset the random. Okay, so I have 500 panes of glass that are just rendering in the middle here. And then we need to offset their positions as well. I guess I need to know the position and angle out here, or at least the position, because that's what I'll be using to sort. All right, I have a bunch of random panes of glass, maybe too many. And let's give them colors. Color. Let's go from like 0.2 to 0.8 just to demonstrate that they are transparent. Here we go. Confetti. And let's turn off some of this random test stuff. Okay, so these are unsorted. And if that's not obvious by the way the colors look, then it should be obvious when we actually look at the draw calls, when we step through in the debugger. Yeah, here we go. So like, I need to drink some water, my throat's getting clogged up. Yeah, if it's not obvious, they are drawing in random orders, random distance. They're drawing it in random order, not sorted by distance currently. So, in theory, adding distance sorting should be as easy as just going to where we're generating these guys. And on the render command, we will add the metadata, which will be the position. I guess we can use the length. So like we'll do position dot length. Or I guess we have to create a new position minus view or camera. Dot position. Oh, I don't have this as a double. Here, let me just calculate this out here. Dot length, and we will sort by the square distance. So there we go. There's our distance, our double. And then, oh, it should set. Should be set. And then rather than committing these directly, we have to create a render graph. So we have a graph. Now we need to make this pane.work. And this is a GFX work variable, I think, because all I need from here is random. And I think everything in there, oh, we need position. I can calculate position as part of angle, maybe. Let's just create a structure. I'll just make the angle. Oh no, I've lost video. Sometimes my graphics card just drops the video, or my capture card. Let me fix that. All right, should be back. So I'll call it like position, and the angle will just be the W component. Okay, that's a buffered command. Delete that. Creates this color randomly based on random. Uploads it. Buffered everything else. So then we just submit this to the graph. The pane. And then once we're done with all of that, we sort the graph. Render, graph, sort. Get the graph, we write our little sort lambda thing. So we have a void pointer meta A. So double A equals reinterpret cast double B, so like distance A, distance B, B, return. Now we draw this. Now in theory, this should just work. We only see one of them though. So what did I do wrong? Am I only adding it? I'm adding it in the loop, right? Yeah. Fascinating, fascinating. Well, it is drawing it a ton of times. It's just drawing it in the same position, which tells me that the it is a nice pane. What does that tell me, actually? I guess the question is, are they actually sorted now, or is it the position that's broken? So close. Let's see. Let's see if these are actually sorted. Because they might be sorted, but they're just drawing in the wrong position. Let me add distance to this. Distance. Yeah, it's a game changer. Because I just have it bound to a hotkey as well. You can just shoot off render doc. It makes life so much easier. So we should see a sorted list of distances if this is even working. F. I mean, they look sorted to me. So that much is working. That's interesting. So it's just not drawing them at a random position anymore. And why would that be? The color was working. It's like this first field isn't being oh, this is on the stack. I'm giving a reference. This shouldn't be a reference. You should just be copies. This one should be a reference. There we go. Whoa. The colors change as I move around. That's trippy. Oh, I guess now the randomness is actually based on the order in which they draw. Let me fix that. Because it's like taking the randomness as like the next float from this random class. But if the order in which this is executing is changing, obviously the values are not going to be like deterministically the same anymore. Okay, I should just pass the color in. Why not? Let's just calculate all of these outside. So this isn't the most efficient layout for your data, but I don't need the pass distance anymore. I know that that works. Okay, and get rid of that. Equals args.color. What's it mad about? Color. Is this fake? Expected a closing. Yeah, it does expect that, doesn't it? Here we go. I mean, does it even look right? I don't even know. I guess I don't have depth testing on. I should turn the depth test on too. Because I'm not depth testing. I'll do less. Or wait, you don't want depth testing if you're doing Oh, you want to sort back to front, obviously, for transparent stuff. Yeah. I was thinking forward to back. Or front to back. Alright, now if we render dock this. I already know this works, I'm just having fun. There we go. A nice sorted list. Now I wonder what the cost of this is. So like if I profile this, oh shoot, I just closed out VS Code. If I profile this, what does this actually cost? I think it should be pretty quick, but we'll see. So we start the timer, stop the timer. How many milliseconds? We'll do like 0.2 milliseconds. Maybe that's not enough. And we want this in milliseconds. Okay, 0.3 milliseconds isn't great, actually, for 500 objects. Not ideal. Or 0.35. That's a significant amount. Let me see what it is on a release build. Oh yeah, much better. Look at that. 0.4 millisecond or 0.04 milliseconds to sort. You can see the pop in though, as it's like choosing which one is in front and which is in back. Because it's not perfect, of course. That's satisfying that works. But just to be sure I'm not doing something stupid, I'm gonna run with the address sanitizer on. Because it's always possible I'm like writing out of memory somewhere. All right, I think we're good. To really center my my panes as well. Should be like yeah, 'cause now the distance will be slightly more accurate. Some weird behavior. It's like it pops in and out. I think my simple sorting heuristic isn't like the most intelligent way of doing it, but it works. But I think that's a good time to end the stream. I'm getting hungry, and I'm satisfied with the progress. So that was fun. So yeah, thank you guys for watching. I'm glad there are more people out there that find this interesting. But yeah, I'll stream again most likely on Sunday. So look forward to that if you are free on that day. So.